All right, today we're doing lesson 3-2, estimating products, and the I can statement is I can estimate products using mental math. You always bring your brain with you everywhere you go, so this is using your brain to help you solve problems. The Solve and Share School Club wants to buy shirts for each of its 38 members. Each shirt costs $23. About how much money will all the shirts cost? Solve this problem any way you choose. And that keyword that you see in there, about, tells you that we're looking for an estimated answer. So there's a couple different ways you can do this. In the reasoning, are you asked for an exact answer or an estimate? And the about tells you that you are looking for an estimate. Now, of course, you want to get as close as you can to the actual answer. So there's going to be a lot of different ways we can do this. You can use rounding or compatible numbers. Where the actual equation, if you were to solve it, you would be doing 38 times 23. So if we were doing rounding, we'd probably round this to the nearest, the largest place value. So that we would round the 38 up to 40 and bring the 23 down to 20. Closer, the largest tens we're going to, which is the largest place value there. And solving a simpler problem, 4 times 2 is 8. And we've got 2 zeros to annex. So 800, that would be one way. That would be using estimation. Using compatible numbers, starting with 38 times 23, I might use round this up to 40 again. And maybe I'll make this 25. Why am I picking 25? Because I know 4 times 25 is 100. And then I'll annex 1 zero. So in this case, this is compatible numbers. That's when I'm using numbers that work well with each other. Like 4 times 25 is 100. That works well together. So that's why it's called compatible. And we can remember that from when we were adding in our last chapter. So which one would be closest? So out of curiosity, and just to move ahead a little bit, I'm going to actually find the actual answer, just to kind of preview our partial products and our multiplication algorithm. And remember, what we're doing here is we're saying 38 times 3. We're starting using the distributive property. We're actually thinking 38 times 3. That's what we're doing first. I'm kind of ignoring that 2. And we're just doing 38 times 3. So 8 times 3 is 24. Put the 4 down and carry the 2. 3, so I did that, 8 times 3. Now I'm going to do 3 times 3. 3 times 3 is 9, plus 2 would be 11. Now I'm going to do 38 times 20. And I can actually annex a 0 here, so I can just use smaller numbers here and say, instead of 20, I'll say 2 times 8, because I already put my 0 down. 8 times 2 is 16. Put the 6 down, carry the 1. And 2 times 3 is 6, plus 1 is 7. I'm going to add them together. So those are my partial products. This is moving ahead into the next lesson. So there's my answer, 874. So which is closer, my estimation on this one or my compatible numbers? So you take a look and decide which one do you think is closer. And if you said that the estimation was closer, you are correct. So the estimation is actually closer than the compatible numbers, but both of them would be fine. Either way would be fine. They're both close. So those are 2 different ways you could solve that problem. And estimating is not actually using the real numbers. It's using numbers that are darn close to it that you're able to work out in your head. So it might be a little different for different people that are watching the video. It depends on what your mental math strengths are. So down the bottom, how can you use number sense to tell the exact answer has to be greater than 6,000? So how do we know the answer's got to be greater than 6,000? Well, if we have 38 times 23, to get 6,000, we could do 38 times 20, or 600, sorry. And what I did there was, this is an underestimate. And I call it an underestimate because I brought my numbers lower than the actual. I took my factors lower. I rounded them down. So I know when I round down the 38 and round down the 23, my final answer is going to be an underestimate. So I know the actual answer is going to be larger than 600. So that is using number sense, the sense of numbers. So let's take a look. Common sense, sometimes you might hear it referred to. So let's take a look at the page that is reviewed in the video. You can always watch that video online in Savvis if this doesn't make sense to you as I walk you through it, or just to reinforce. Essential question: how can you estimate products? A store needs at least $15,000 in sales per month to make a profit. If the store is open every day in March and sales average $525 per day, will the store make a profit in March? You can use rounding to estimate. Is the sales total for March at least $15,000? So what do we need to do as we move down? Use rounding to estimate. So $525 a day can round to $500. 31 days in the month can round to 30 days. Finding 30 times 500, we solve a simpler problem. 3 times 5 is 15. And then we bring 1, 2, 3 zeros over. So we have 15,000. So will the sales be at least 15,000? Now let's take a look at what we did. We rounded down the amount and we rounded down the number of days. So this is going to be an underestimate. Both numbers are below the actual number, so we know our final value is an underestimate. So the store will make more than $15,000. So that is an underestimate, and that would work. A different store needs to make at least $20,000 to make a profit in March. They average $685 a day for the month. James uses rounding and estimation to say that 685 is almost 700. 700 times 30 is 21,000. I think it's going to be a close call. What do you think? I agree with James. That's really close. So he rounded up $15 to get to 700 is the nearest 100. So there's not a lot of wiggle room here. So it's pretty close. And if he were to actually try to figure out what his answer was, he could multiply 685 times 31. I'm going to go through that just as a little preview of what's coming down the road. Using the distributive property, this one you can kind of take a little shortcut on, because remember, when you're doing multiplication algorithm, the first partial product is just 685 times 1. And I bet you all can get that one without even doing anything fancy. 685 times 1 is 685, because it's just one time. The second partial product will be 685 times 30. So that might require a little bit more of a process for you. So let's go back to the original problem. And remember, this 5 times 3 is really 5 times 30. I'm going to put a 0 there just to put a placeholder there so I don't accidentally start my number in the wrong spot. We want to make sure they're added up in place value, or they're listed in place value, so when we add them, we have the correct final add-in, final answer here. It's actually a product. 5 times 3 is 15. I put the 5 down and carry the 1. 3 times 8 is 24, plus 1 is 25. Put the 5 down, carry the 2. 3 times 6 is 18, plus 2. 18 plus 2 is 20. I'm going to add them all up. And I have 21,235. So we were shooting for 21,000, and it is really close. So it is we know this is an underestimate because, why do we know that? We don't know that. We can't really tell. So that's really close. So we'd have to find the actual answer. But that's going through and reviewing that algorithm a little bit for you. That will be coming up shortly. The double-digit multiplication. It's really a good time to make sure you're getting those multiplication VIFs out of the way. They will help refresh your memory on multiplication. So try to really be working on those VIFs and get them done. And finishing up today's lesson, doing a little guided practice and another example. Estimate 24 times 398. So a couple different ways you can do that. We can look for compatible numbers because 25 is very close to 24 and 4 is a compatible number. And why did they pick 4? Well, because if you look at the largest digit in the value there, 398, the largest place value is the hundreds. And the digit in the largest place value is a 3. But this is why they had you doing that estimation in the very beginning. What does that estimate to? 398. If I'm rounding to the largest place value, I underline the 3. That means the 9 is going to either make the 3 go up to a 4 or leave it alone. And the 9 is greater than 5. So when you're estimating 398, like if you were putting it on a number line, and we have is it closer to 400 as the largest 100, or is it closer to 300? If you were to stick it on a number line, you'd be putting it way over here by 400. So that's where they got that 4 from. So 4 is close to 25, and 4 and 25 are compatible. Those are numbers they think you can do in your head. And if you think about quarters, 4 quarters is 100 cents. So 25 times 4 is 100. So that's where they're getting that from. So 10,000 is a good estimate. So 25 times 400, 25 times 4 is 100. Bring 2 zeros over. Put your comma in there. So 10,000 is a good estimate, and it is an overestimate. Why is it an overestimate? Because you only rounded up 2 little guys here, and you rounded this up by 1. So 10,000 is an overestimate of the actual value because you rounded both values up, but it's very close to the actual answer. When you round both values up, you wind up with an overestimate. If you round both values down, you wind up with an underestimate. Okay? And into your guided practice. Couple little problems here. There's actually not a lot on the page, but you probably are going to need a notebook to set up your work. Each egg carton holds 1 dozen eggs. Michael's chicken farm fills 121 egg cartons. He thinks that there were over 1,500 eggs. Is he correct? Use an estimate to find out. So we are doing 121 egg cartons. Each egg carton holds 1 dozen eggs, and you have to know that 1 dozen equals 12. If you don't know what that is, you have a computer in front of you. Google it. What does 1 dozen equal if you forget? So let's see if we can get this figured out. So we're thinking 1,500. Does that look right? There's a couple different ways you can do this. You can, if you know your 12 times tables, you can use compatible numbers and do 12 times 12. 12 times 12 is 144, and bring that 1 0 over. If you don't know your 12 times tables and you want to just you can actually, when you're estimating, you can leave one number alone. We can leave 121 alone and just change to make the 12, round it down to 10. So we can do this, 121, and annex that 0. So he thinks that there were over 1,500 eggs. Do you think he's going to be right there? Is he over 1,500 eggs? No, he's not going to be right. Just on our 2 estimates, we can see he's not correct. Okay, so when you're using your notebook for the next work, you can, if you need to use your notebook, you can. If you don't need to use it, you might be able to fit it in next to this here, but underneath there's not much room for the independent practice. But let's see, we can estimate and then decide if it's an overestimate or an underestimate. So let's say, and when you're estimating, you're usually going to the largest place value. You're estimating to the largest place value. They're not going to tell you that. It's understood. So in this case, we'll be rounding to the tens. This one we'll be rounding to the hundreds, to the hundreds, to the hundreds, to the tens, to the hundreds, to the hundreds, to the hundreds. The largest place value. So 29 rounded to the largest place value is 30. 688 rounded to the largest place value is 700. Find my answer. Solve a simpler problem. 3 times 7 is 21. And bring my three zeros over. And did I round up on both numbers? Yes. So that is an overestimate. The next one, rounding to the largest place value, 200 times 700 is 2 times 7 is 14, and I have 4 zeros. 1, 2, 3, 4. And is this, did I rounded down for this one and down for that one? So it's an underestimate. I rounded both numbers down. So 140,000 is below the actual answer. So it's an underestimate. For number 4, rounding to the largest place value, 43 rounds to 40. 108 rounds to 100. Solve a simpler problem. 4 times 1 is 4. And I've got 3 zeros. 4,000. I rounded this value down. This value down. So again, I rounded both values down, so it is an underestimate. The next one, rounding to the largest place value, 400 times 700. I rounded both values up. I can tell it's going to be an overestimate. And to solve it, 4 times 7 is 28, and 4 zeros. All right, now you can go off into your buddy work, or you can continue on the independent practice. And don't forget that you've got that Common Core assessment practice, which I'm going to zoom over to real quickly. I really want you to get in the habit of doing these. If you are doing the buddy work, they show up on the buddy work. It's just really important that you do this test review stuff. It helps you out with your topic tests, and it's actually getting you ready for the PSSAs too. And again, these will be in your buddy work, but I just want to go over them together in the book work as well. So they're on the problem solving page. You can find it on the homework page too. There's even more there. So Lance has 102 packages of sports cards. Each package has 28 cards. Use rounding to estimate how many cards does Lance have. So they want me to round. I have 102 times 28. I'm going to round to the largest place value. So when I do 30 times 100, remember 3 times 1 is 3. It's not going to be either of those. And I'm going to have 3 zeros. So there we go. You only had to solve one problem there, which does not show a reasonable estimate for 24 times 338. Well, let's first of all figure out what we're going to have for here. If we go to the largest place value, the 2 and the 3, this would round to 20 because 24 is closer to 20 than it is to 30. And this would round to 300 because 338 is closer to 300 than it is to 400. When we multiply, 2 times 3 is 6, and I've got 3 zeros to annex, which would be 6,000. So which is not reasonable? Okay, well, that one looks good, 7,000. I would say 6,000, because these are both, this is an underestimate. We went under on both, so that would be on the lowest end. Well, we could have 7,000 if we rounded up, maybe 25 times 300. We did that. 25 times 3 is 75, and 2 zeros. That one would look good. And 700 would be good because it's in between both of those. So the one that would not be reasonable would be 10,000. That would be way too big. By 5th grade, they're expecting you to get close to the actual answer when you estimate. All right, there you go. Have a great day.